Right, so this is 6 circular motion questions tube. There are 100 new questions in this tube. We have already discussed the first 5 questions. Therefore, I'm not going to discuss the first 5 questions. I'm going to start my discussion with the question number 6. Question number 6. A small metal ball is wheeled in a circular path with a constant angular acceleration. If its acceleration is changed from 10 hertz to 40 hertz within t seconds, there's a small typing mistake. Not the acceleration, but the velocity. It's velocity. That's a typing mistake. It's velocity. Please correct the mistake. Its velocity changes. Its velocity, not if is, its velocity is changed. Its velocity is changed from 10 hertz to 40 hertz. Its velocity is changed from 10 hertz to 40 hertz within simple t seconds. The number of cycles completed by the ball is 30 times 5. Calculate the time taken and angular acceleration. Calculate the time taken and the angular acceleration. So let me make this space white, or even I can use my whiteboard also. But okay, I'll use this. Right. So what are the things that they have given? Velocity change from 10 hertz to 40 hertz. How do we convert a frequency? Hertz means actually frequency. How do we convert frequency to angular velocity? What's the equation? Omega equals
2 pi f.
2 pi f. Very good. 2 pi f. So by using this equation, we can convert these two initial angular velocity is given as 10 hertz. After t seconds, angular frequency is 40 hertz. So we can find initial and final angular velocities by using this equation. Right? So I'm going to use this equation to calculate initial and final angular velocities. So initial angular velocity is omega 1, that is equals to 2 pi. F is given as 10. F is given as 10. So 2 into 5 into 10. Now the unit is radian per second. Now the unit is radian per second. Right? So this is 2 into 5 is 3.14 into 10. Right? So 2 times 3 is 6. 2 times 3 is 6.28, should be multiplied by 10. Right? So then we will get 6.28 multiplied by 10 means 62.8. Unit is radian per second. It's completely. So this is the first thing that you want to do. Convert angular velocity from hertz to radian per second. I have said that, I have explained that angular velocity can be given as frequency, and angular velocity can be given as time period, angular velocity can be given as r period. So here they have given the angular velocity as hertz. So we have to convert hertz into radian per second like this. Okay. Or you can keep, without simplifying this, if you want, you can keep this as 20 times 5. So please write this value also separately. So you can keep angular velocity like this without simplifying. Without simplifying like this, you can keep angular velocity as 62.8 radian per second or 20 times 5 radian per second, as you wish. Right, now let's do the same to the other angular velocity. What's the other angular velocity here? After t seconds, angular velocity is given as 40 hertz. So let me use the same equation. Omega 2 equals 2 into 5 into f2 pi f40. F is 40. So if you multiply this, you will get 40 times 2, 80 times 5 unit is radian per second. Radian per second. But if you want, you can simplify like this also. That is also possible. 2 into 5 means 3.14 into 40. So this is also possible. So 2 times 3.14 means 6.28 into 40. So if you multiply this, you can multiply all the things by 4 by writing a 0 first. 4 times 8, 32, 3 remaining. 4 times 8, 32, 3 remaining. 4 times 2, 8 plus 3, 11, 1 remaining. 4 times 6, 24 plus 1, 25. There should be 2 decimal places. That is 251.20 radian per second. Right, so you can keep angular velocity in any of these formats. Complete here. Write them all. Right. The next thing that we should identify is this circle here. So if you consider one circle, right? So let's say a particle starts its motion, a small metal ball. Right? So let's say metal ball starts here in this position, and let me mark the radius. Actually, you should mark radius with the dotted line. It's very difficult for me to draw a dotted line, so I use a continuous line like this. If the particles start at this position, and if it comes back to the starting point like this, so what is this angle in decrease here? What is the angle of one cycle in decrease? Lamai?
360 degrees.
360.
Very good. So angle of one cycle is 360 degrees. In radian, how much?
2 pi.
radian.
2 pi radian. So if this motion completes only one cycle, what will be the rotated angle here? If this motion completes only one cycle, what is the rotated angle in radian?
2 pi radian.
2 pi radian. But how many cycles are completed here? The number of cycles completed by the ball is 30 times 5. So how many cycles are completed here?
15.
50.
30 times 5. 30 times 5. 5 means 3.142007. So if one cycle completed, the rotated angle will be 2 pi radian. Now it has completed this much of cycles. Therefore, what will be the rotated angle here? What should I do to find the total rotated angle?
35 into 2 pi.
Very good. 30 times 5 should be multiplied by 2 pi radian. Then we will get the complete rotated angle. Right. Before that, please draw this figure. Please draw this figure. This figure refresh our memory that angle of one cycle is 2 pi radian. Angle of one cycle is 2 pi radian. So we need this knowledge for this question. Draw the figure and mark these details. Right. Now below the figure, let's write several statements and finally we can obtain the answer. Right. So please write angle of one cycle. Angle of one cycle equals 2 times pi radian. Right. So therefore, the rotated angle, for rotated angle for 30 times, they have given 5 even here to make you confused. Therefore, the rotated angle for 30 times 5 cycles. So you should not be confused by because even 5 is there. Even 5 is there, don't worry about it. So angle of one cycle is 2 times pi radian. Therefore, angle of this much of cycles. What should I do here? I should multiply. I have a manager space, that's why I have written like this. So 2 pi should multiply by 30 times pi. Right. So if you want, I can put it into a square brackets, right? So this is the complete rotated angle. Angle of one cycle 2 times pi radian. Therefore, the rotated angle for 30 times pi cycles is this. So if you get this multiplication, 30 times 2 will be 60, and 5 into 5 will be square of pi. So this is the rotated angle. Right. Now somebody unmute the mic and tell me the definition of angular displacement. What is the definition of angular displacement?
The rotated angle in radian.
Very good. Angular displacement is the rotated angle in radian. So the rotated angle in radian is rotated angle in radian is 60 times pi square. Rotated angle is 60 times pi square. Therefore, the angular velocity. angular displacement. Therefore, the angular velocity. Therefore, the angular velocity equals 60 times pi square. Unit is radian. So this is what we wanted to find. This is the thing that I really wanted to find. So we know the initial angular velocity, we know the final angular velocity, and we know the angular displacement. And we know the angular displacement. Angular displacement. So what are things we know? Initial angular velocity is 20 times 5 radian per second. Final angular velocity is 80 times 5 radian per second. And the final angular displacement for simple t seconds is 60 times pi square. The unit is radian. Completely clear? Right, so the easiest equation that can be used to solve this problem is time is not given. You have to find the time. Therefore, the easiest equation is omega 2 square equals omega 1 square plus 2 alpha theta. What is the easiest equation for this question here? Omega 2 square equals omega 1 square plus 2 alpha theta. Try to solve the problem without my help. Try to find alpha without my help here. Right, I use my normal board for the simplification. That will be much easier. Right, if I use my normal board, that will be much easier. The equation that I am going to use is omega 2 square equals omega 1 square plus 2 alpha theta. Omega 2 is 80 times pi, 80 times pi square. Omega 1 is 20 times pi, 20 times pi plus 2. Alpha we don't know. We don't know what the alpha is. Alpha is angular acceleration. We don't know it. But theta is known. Theta is 60 times pi but square. 60 times pi but square is there. So 60 times pi, but you should get square. Pi square, not like this. Pi square. Eh? Only the square of pi, no square with 60. No square with 60. Only pi has the square term. Right. So 80 square pi square. That's what happened when you remove the brackets. Similarly, 20 square pi square. That's what happens when you get the square. When you remove the brackets, a square term should be written separately for the two terms. So this is 2 into alpha into 60 into pi square. So once you write like this, it's very much clear that all the pi square terms are cancelled out. All the pi square terms are cancelled out. So what are the remaining terms here? 80 square. 8 times 8, 64, double 0. 20 square, 400. Plus 2 into 60 is 120 times alpha. Take 400 this side, 6,400 plus 400 come this side as minus 400 equals 120 times alpha. 6,400 minus 400 means 6,000. 6,000 equals 120 times alpha. Take 120 this side, 6,000 divided by 120 equals alpha. Right? So finally, you will obtain alpha equals 0, 0 cancelled out. 600 divided by 12. 600 divided by 3 is 200. 12 divided by 3 is 4. 200 divided by 4 means 50. So angular acceleration is 50 radian per square seconds. 50 radian per square seconds. Who got this answer? Please raise your hand up in the Zoom chat. If you got this answer, please raise your hand up in the Zoom chat, Lamai. Okay, very good. Interesting. How do you find the time taken? How do you find the time taken for the motion? Lamai?
Apply omega 2 equals omega 1 plus alpha t.
Very good. We can use the equation. Excellent. What's the equation? Omega 2 equals omega 1 plus alpha t. Very similar to V equal U plus A. This is very similar to V equals U plus A. Omega 2 equals omega 1 plus alpha t. Omega 2 is 8 times 5. Omega 1, 20 times 5. Alpha, 50. Alpha is 50 times t. So I can take 25 with this side. 80 times 5 minus 20 times 5 equals 50 times t. 80 minus 20 is 60 times 5 equals 50 times t. Take 50 to this side. 60 times 5 divided by 50 equals t. 0, 0 cancelled out. So time taken is equal 6, 5 divided by 5 seconds. Is this correct here? Who got this answer? Please check whether my calculations are correct. Is this correct, Lamai? And who got this answer? If so, please raise your hand up in the Zoom chat. Right, very good. But in the examination, you must use the value of pi as 3.14. 3.14 should be multiplied by 6, and that value should be divided by 5. So it means you should give the answer with at least 2 to 3 decimal places. 2 decimal places will be enough for the time. But for my questions, you can keep the answer as a fraction like this. It's okay. But in the exam, please divide. Divide, multiply, and do all the things and give the final answer in the exam. But here, fractions are okay.